Right, here we go. Oops, sorry, I've left one of my timers running. Let's turn that off. Right, here's our first question for today on today's live stream. We're doing sheet number 6 from our revision series in A-Level Maths. And we've got a nice little addition formula problem to start off with. I'm not going to give you too long. It shouldn't take you too long to do this. I'll give you 60 seconds to start this one. Right, my class is struggling with this. I'll give you another 60 seconds. Here you go. Right, let's have a look at this one. So we're going to do sine A plus 60. So we use this formula. We get sine of A, and then we get cos of 60 plus sine of 60 cos of A. Now, one of my students said, how do you remember what these all are? The cos 60, the sine 60. And what you do is write a little table, sine, cos, tan. All you've got to be able to do is count from 0 to 4. So you do 0, 1, 2, 3, 4. And remember which angles are the ones you've got to remember. 0, 30, 45, 60 and 90. And then there's two ways around we can do this. We can square root them all and then divide them all by 2. And you've got your exact values. And you can see this one's obviously 0, this one's a half. This next one's root 2 over 2, then root 3 over 2, and root 4 over 2 is just 1. Okay, you can simplify them. Then cos, all you've got to do is write them in the opposite order. So we get 1, we get root 3 over 2, we get root 2 over 2, we get a half, and we get 0. And then tan is just sine divided by cos. So that's going to be 0 divided by 1 is 0. Half divided by root 3 over 2 is going to be 1 over root 3. And then that divided by that is 1, that divided by that is root 3, and this is undefined. So that is how you can remember them. I personally just remember the special numbers and just remember the shape of sine goes from small to 30, 45, and 60. And I use a half, root 2 over 2, and root 3 over 2 for those, and obviously 0 and 1. And then cos, because it goes the other way, I just remember they go the other way. And tan, I just remember those off by heart. So there's lots of little different ways you can use to help you remember these exact angles. Or you can use your calculator, because most papers have calculators anyway. So cos of 60 is equal to half, so it's going to be equal to half sine of A. And then we've got sine of 60, which is root 3 over 2. So we've got plus root 3 over 2 cos of A for part A. And B, we get cos of 30 minus B, that's equal to cos of A, so it's cos, we'll make 30A, cos 30, cos B, and if we've got minus here, we get a plus there. and we're going to get sine of A, so sine of 30 cos B. And cos of 30 is equal to root 3 over 2, so you get root 3 over 2 times cos B, plus sine of 30 is a half cos. Sorry, there's a mistake there, apologies. That should be a sine. So that should be sine B just there. Apologies for that little mistake. So let's look at the next question. And we got question 2, and we're going to do some exact angle problems using the addition formulae. I'll give you 3 minutes to try and do this question. Right, so we're going to show if sine A equals 3/5, then cos A is plus or minus 4/5. Well, we know that sine squared of A plus cos squared of A is equal to 1. So sine squared of A is equal to 9 over 25 plus cos squared of A equals 1. So take that away, we get cos squared of A equals 9 off 25 gives us 16/25. So therefore cos A equals plus or minus 4/5. Now we're going to try and work out the possible values of cos A and B if we've got sine A equals 3/5 and cos B equals 12/13. So we know that cos A plus B is equal to cos A cos B minus sine A sine B. Now what we've shown, if sine A equals 3/5 and cos A equals plus or minus 4/5. Similarly, we can show that cos B equals 12/13. Hopefully you know your your Pythagorean triples. Then sine B is plus or minus 5/13. So what we can have here is we can have cos A, which we've already shown to be plus or minus 4/5, cos B times 12/13 minus, and we've got sine A is 3/5, and then sine B, remember what I said, it's going to be plus or minus 5/13. So times by plus or minus 5/13. So you get all those possible combinations, and when you multiply them out, you can get either 33/65, and we're not going to do the calculator work, 63/65 minus 63/65, and you can get minus 33/65. So there's 4 possible answers to this question. If you just want me to quickly go over why the sine B is plus or minus 5/13, here's what happens. So we know that cos B, so we've got cos squared B plus sine squared of B must equal 1. So therefore cos squared is 12/13 all squared plus sine squared of B equals 1. And basically if we go on and simplify that, we get sine B is equal to plus or minus 5/13. I'll leave you to do the arithmetic and work that out. Right, the next question, I can find it. Here we go. We've got to rewrite these as a single trigonometric function. I'll give you 5 minutes to start off with, see how the class with me does. Maybe I stop this early. 1 minute to go. This theta goes to a 2 theta, so 2 theta should go to a 4 theta. So if we have 2 sine 2 theta and cos 2 theta, we will get sine of 4 theta. But we got 6 of that, so it's 3 times that, so we should get 3 times this. So 6 sine of 2 theta cos of 2 theta will equal 3 sine 4 theta. Now for part B, we're going to do double angle formulae twice. We're going to do a little bit on the sine theta cos theta. So we can rewrite 4 sine theta over 2 cos theta over 2. Now if we're doubling these to get our from theta to 2 theta, we're going to go from theta over 2 to theta. So this is going to be the same as 2 sine theta, because we've doubled that to get that, because we doubled that to get that, doubled that to get that. So we've got 4 sine theta over 2 cos theta over 2. Remember not to forget the cos theta, so let's put that in. And that's going to be equal to 2 sine theta cos theta, which is just equal to sine of 2 theta. So there's our 2 answers. Just a quick note on the previous question, if I just scroll back up again. Somebody asked me how I knew these. I just happened to know, okay, that 5, 12 and 13 is what we call a Pythagorean triple, that 5 squared plus 12 squared is equal to 13 squared, is how I happen to know to do those so quickly. So that explains that one. Okay, question 4. Find the derivatives of the following products of functions. Got a bit of products rule, and on one of them a little bit of chain rule going on as well. So have a go at that. I'm going to reckon you should be able to do this in 3 minutes. Right, everybody in my room has finished, so we'll stop the timer there and just go through them. So if we do x e to the 2x using the product rule, so we're going to differentiate the x and times by e to the 2x. So if we do d dx of x e to the 2x, differentiate the x, we get 1, times by e to the 2x, we just get e to the 2x. Differentiate the e to the 2x, we get 2e to the 2x, and we've got to times that by x. So we get 2x to the e times e to the 2x. And if you want, you could factorise this. It doesn't really matter if you do or you don't, especially if the question doesn't specify. So there's A. B. Now we've got a bit of chain rule going on here when we want to differentiate that bit. And you should really make sure you get to the stage where you can do chain rule in your head. If you can't, you're going to find some of the trickier integrations quite difficult to do and difficult to spot the reverse chain rule problems. So we're going to differentiate this. We get 2x plus 1 times e to the 3x. Actually, it wasn't a chain rule problem. I don't know why I said that. Plus, this is a sort of semi-chain rule problem. We're going to differentiate the 3x, so we get 3. So we're going to get 3e to the 3x times x squared plus x. So we get 3e to the 3x times x squared plus x. I suppose I could factorise this a little bit. So I get e to the 3x, and I get 2x plus 1 from that one. I'm going to get 3x squared plus a 3x from this one. Combine it all a little bit. So e to the 3x, and we've got 3x squared plus, I've got a 2x and another 3x, that's 5x, and I've got a plus 1 there. Let's do c over here. So I want to differentiate this, shouldn't take us too long. X cubed is 3x squared times by the sine x, plus the sine which goes to cos times by x cubed, so x cubed cos x. And I don't think there's anything to be gained by trying to factorise that one at all. Right, so that's question 4. Let's move on to question 5. There's no questions so far in the stream. So question 5, show that x minus 2 is a vector and solve this equation. I think, again, this is probably a 2-minute problem. Here you go. Right, sorry about that. I got distracted there. So here's this question. We're going to show that x minus 2 is a factor. So what we do is we do f of 2, because if f of 2 equals 0, then x minus 2 is a factor by the factor theorem. So 2 cubed minus 2 squared minus 3 times 2 plus 2. So that's equal to 8 minus 4 minus 6 plus 2. So you've got 10 minus 10 is 0. Therefore, x minus 2 is a factor by the factor theorem. And you probably got to you do have to quote that you're using the factor theorem. Okay, now we want to solve the equation f of x equals 0. So x cubed minus x squared minus 3x plus 2 equals 0. We can take x minus 2 out as a factor, which means if we factorise that, we know that we've got an x squared here, because x times x squared is x cubed, and we need a minus 1 here, because minus 2 times minus 1 gives me the plus 2. So this will give me a minus 2x squared when I only want a minus x squared. So I need a plus x here, because plus x times x gives me a plus x squared, minus 2x squared will give me the minus 2x squared I need. Check against the minus 3x. Minus 2 times x is minus 2x, minus 1 times x gives me the minus 3x, so that works too. So we know that x equals 0 or x equals 0, sorry about that. X equals 2 here from this one, or we've got x squared plus x minus 1 equals 0. Now I'm just going to complete the square on this because I find it quicker to do. So I've got x plus a half squared. I'm going to minus a half squared minus 1 because I want that to cancel with that. That's equal to 0. So I'm going to get 1 and a quarter on the other side. So I'm going to get 5 over a quarter on this side equals x plus 1 squared. And then square root that. So I get plus or minus the square root of 5 over 2. And take away 1. So x equals minus 1 plus or minus the square root of 5 over 2. Right, next question. Trickier question. This is definitely at least 5 minutes, probably even longer than that. See how far you can get doing on this question in 5 minutes. Here you go. 1 minute to go. I'll give a 2-minute extension to this question. Bear in mind we've only got one more question and the class are finding it difficult to complete. Right, here we go. So we've got a closed rectangular box made of thin card. Its length is 3 times its width. The height is h and the width is x. So let's just draw that out. So we've got height, we've got width of x, and we've got length of 3x. So therefore the volume is going to be equal to x times 3x times height. So it's equal to 3x squared h. And we know that's 972. And that's equal to 3x squared h. And we want to get an expression for h in terms of x. So therefore h will equal 972 over 3x squared. Then we want to show the surface area can be written as this. So we know the surface area is going to be equal to 2hx plus 6hx plus 2 times 3x squared. Because you've got xh here, xh on the other side, so that gives you 2hx, 3x squared on the bottom, 3x squared on the top, so there's 2 of those. And then we've got an h times a 3x, and we've got 2 of those to give us a 6hx. So therefore the area must be equal to, we know h is this, so we've got 2x times 972 over 3x squared plus 6x times 972 over 3x squared plus 6x squared. So we can combine this all together and we will get 2592. The x will cancel out with the x squared there. The x will cancel out the x squared there. So we add these two top things together and we get 2592 over x plus 6x squared. So that's our area. Now we want to find dA by dx. So dA by dx is equal to, what we're going to do here. So we're going to differentiate that. I'm going to get 12x. And then I'm going to get a minus 1 coming from the power of this, because it's 2592 times x to the minus 1. So we're going to get minus 2592. And we're going to take 1 off that power, so it'll be x to the minus 2. So it's over x squared. Now we want to find the stationary point, so that must be equal to 0. And therefore we're going to take this to the other side, and then we're going to get times by x squared. Actually, let's not do too much in one go. I made a mistake here. I've lost an x here. Sorry about that. I lost an x there. So let's just do that. 2592 over x squared is equal to 12x. Times throughout by x squared and divide by 12. I'm going to get 216 when I do 2592 divided by 12 equals x squared times x is x cubed. Cube root of 216, I get x is equal to 6. Now we want to find the second derivative. So that was part A, part B, part C. So we've got a bit more part C. So C continued. So we want to find the second derivative of this, and that's just going to be equal to 12 plus 2 lots of that, 2 times 2592 all over x cubed. Then if we put x into this, x is 6, so when you put 6 into this, you've got a positive number divided by a positive number added onto a positive number. So we don't even need to work it out. We can just see at x equals 6, we know that the second derivative is greater than 0. So therefore we have a minimum turning point. Okay. So hence we can find the minimum surface area. Well, what we do is we just use the formula for the area, and we're going to get 2592 over 6 plus 6 times 6 squared, which equals 648. And then we can find the dimensions of the box. So we know that x is 6. We know this is going to be 18. And we found a formula for h and x. So do 972 divided by 3x squared. What we get is we get the width equal to 6, the length equal to 18, and when you put that in, you get the height equal to 9. And it's quite important you remember to read the whole question. It's so easy at this point just to find the minimum surface area and possibly miss out the dimensions of the box. I'm sure I did that the first time I had a go at this question. Right, our last question, another 5-minuter, but it's another long one. Here you go. 1 minute to go. Just give you another minute because the class with me seem to need a bit more time. Right, here we go. So, a circle has 2 points, -1, 3, and 5, 11, as ends of the diameter. Find the equation of the line PQ. So, we want to first of all find the gradient of PQ. So, the change in y from 3 to 11 is 8. Change in x from -1 to 5 is 6. So, we have 8 over 6, which equals 4 over 3. So if we use y minus y1 equals mx minus x1, that's the form you should use. Y minus y1 equals mx minus x1 is the quickest way to get to the equation of a line. y1, x1 is a point on the line, m is the gradient. So y1, let's just pick -1, 3 is my point on the line. So y1 is 3 equals m, 4/3. Times x minus x1, and x1 is -1, so it's going to be +1. And that's the equation of my line. It doesn't ask for me, and if you go over an equation line, so I could just leave it like that. But I'll just rearrange it just to make it look a bit nicer. So you get 3y minus 9 equals 4x plus 4, times by 3 to get them, times the brackets out. So what shall we write here? 3y equals 4x plus 13. I'm just going to leave it like that. So for part B, okay, to find the equation of a circle, well, the first thing we need to do is find the centre. So it must be at the midpoint of PQ. So the midpoint of PQ will be where the average of the x values, so we've got -1 plus 5 over 2, and the average of the y values 3 plus 11 over 2. So the midpoint is going to be 2, 7. So, and we can find the distance from P to Q to get the diameter, and then from that we'll be able to get the radius. So the length of PQ is equal to 5 minus -1 all squared. Sorry, it's meant to be a squared there. Let's just rub that out and write it neater. So we have squared plus 11 minus 3 all squared. So that is equal to 36 plus 64, which comes out to be equal to 10. So therefore the radius equals 5. This means that my circle, the centre, is going to be 2, so you should know that the form of a circle is x minus the x coordinate of the centre, y minus the y coordinate of the centre, equals a radius squared, so equals 5 squared. The line y minus 7x minus 4 cuts the circle at P and another point R. Find the coordinates of R. So what we can do is, I'm just going to move across to give myself a bit more space. So it's y equals minus 7x minus 4. So know that y equals minus 7x minus 4. So I'm going to put this in for y in here to solve the equation. So I'm going to get x squared, x minus 2 squared, plus y, not y, because I'm going to replace the y. I'm going to replace the y with minus 7x minus 4, minus 7. All squared equals 25. And if I multiply this all out, what I should get is I should get 50x squared plus 150x plus 100 equals 0. Divide throughout by 50, I get x squared plus 3x plus 2 equals 0. So I get x plus 2 times x plus 1, if I factorise this, equals 0. So x equals minus 1 or minus 2. Now we know p is minus 1, 3, so we don't need that value. We need the r value must be where x is minus 2. So r is x is minus 2. Put minus 2 back into, actually put it into back into here. So getting it plus minus 7 times minus 2 is 14. Minus 4 is 10. So the r coordinate is minus 2, 10. There we go, that's all for today. We'll be back here again tomorrow at 5 o'clock and we'll do sheet 7 then.